started on today. So we're in this phase now, gotten past all the Excel, preview stuff, and we've just looked at a tool that's very useful for what if analysis after we do a model, but we really need to start talking about the modeling process itself. So we're gonna do one really easy model, just real straightforward, very tiny model to introduce some concepts and talk about the way things ought to work, okay? And then we will actually do a data table with that one. And then it's this one. Let me go ahead and just bring it up so we show it to you. This is our really simple example. We sell these NCAA t-shirts. We're gonna be selling them at an upcoming event. There's this fixed cost to ordering, and it's $750. Then we pay $8 per shirt. Okay? We intend to then turn around and sell those shirts for $18. If we have shirts left over at the end of the event, we don't really have much of a market for it, but we think we could sell the rest of them at $6 a shirt. Okay, we think, again, demand is a very, that's kind of an uncertain thing because you're not positive. You do the best that you can. You work at, trying to figure out what it's gonna be. But we think the demand for the shirts will be 1,500. We're a little on the conservative side and we wanna be cautious. So we're not quite gonna order 1,500, we're gonna order 1,450. Okay. So that's our plan at this moment. We're gonna make a little model that'll allow us to look at the profit, and then we'll do a little what if on, what if we're wrong about this? What if demand is higher, we order less, we order more, demand is like, whatever. We're gonna look at all of that with a data table. We're gonna follow that up, if we have time, with starting this model, which is a machine purchase selection decision that we're trying to make. We have two different machines. There are things we know about the product itself that are independent of which machine we buy. And that's that we believe the demand will be 10,000 and we have a 40-cent profit margin on every unit that we sell. So it doesn't matter which machine we use to produce it, that's what we know about the product, okay? Now there are these two machines and they have some differences. They have different annual maintenance costs. They have different annual production capacity. They have different useful lifetime, okay? They have different prices, and both of them have these quantity discount kind of structures, but like their price breaks are at different places. This one's one machine, you pay the highest 2 to 4, this is 1 or 2, 3 to 6, and the prices are different. So those are the things we know, those will be on the spreadsheet. And what we will be trying to do is determine what the best decision is. We'll do that by laying out the cash flows and then going back and doing like financial measurements on them. Which one has the best NPV, which one has the best IRR, which one has the best payback. I mean, that's what we're gonna be looking at in order to make the decision. Then we'll do some data tables. And we won't get through all of this, I can tell you that right now. We'll be doing good if we get through the cash flow. Okay, but we're gonna start out with the really simple one first. And I have laid out some labels so that when we're doing this model together, that our stuff ends up in the same cells. Okay, it just makes it easier. But here's the idea. We are going to set up that little NCAA t-shirt model based off of information somewhere. We have information somewhere. Based off the information that you had that I just had on the PowerPoint a moment ago about fixed and variable costs and all that. What you want to do with any model is set up an input area where you put in your hard-coded known values just up front, up the top, to the left, wherever you want to put it, but you put it somewhere, and then everything after that, as best you can, okay, references back to that section. So we're not going to go down into formulas to calculate profit and be plugging in 18 and 6 and 750. We're not going to be plugging that in. We're going to be putting that in an area and referencing those cells. Because if anything changes, you want one place that you go to make the changes, and all those changes are reflected through the rest of the model. I mean, that's the idea. That's what you want to have happen. So if you were looking just at that PowerPoint, we have a few, we know them, this is what they are, kinds of variables. And what do we have? What are some known input variables that we have? Some costs. What are some costs we have? We have the, how much it is per t-shirt. I'm gonna move this down to the next line because, whoa. So we have the variable cost per shirt, and we were told that that was $8. Okay. What other costs do we have? Well, what, besides variable cost, what is your other cost?
Fixed cost?
Okay, we have a fixed cost, and we were told what the fixed cost, just to place an order, regardless of how many shirts we got, that was $750. What other known values do we have?
Selling price?
Yeah, what are we going to sell it for? So the selling price of the shirt, which we have determined, or they told us we had to do, I don't know, is $18 a shirt. What's another known value that we have? Yeah, a price that we're gonna sell them at. If there are any left over, there's gonna be this discount price. And we're making the assumption that at that discounted price, we would be able to get rid of the rest of them, okay? All models have to have some assumptions built into them. They just do. I mean, there are things that you think, you know, so we're making the assumption that once we dropped it to that, we'd be able to get rid of all the rest of them if we had any left over. Okay, okay, so I have these as our known input variables. There's gonna be this color coding scheme or convention that they use in the textbook. And we're gonna use the same thing. We're gonna use it throughout our model, so you'll get really used to it. It's kind of funny. I don't know what it looks like in the online book, but if you did actually purchase the hard copy of a book, they talk about the colors they use, but the book's not printed in color. So that again makes it interesting, because then you're just looking at, you know, gray tones. But anyway, the color for input that we're gonna use is kind of a light blue color. So there's a blue color. That will designate to us that that was a known, typically hard-coded in, known input value. And this is our little input area. I do have something else that we don't know with certainty, but that we've predicted, and our uncertain variable is what? What's the thing that seems kind of most uncertain of the things that are just listed in a space this big on the PowerPoint? What do you not know with certainty oftentimes? Guys, look at the PowerPoint.
Yeah, the demand.
Yeah, demand is the one thing that you, a lot of times, well, you are, I just know a lot of times, you are always making estimations of what you think that will be. Your marketing research is either really good or not really good, so you may be accurate or you may be not accurate, and I did not want that to format that way. Okay, so our demand, 1,500. There is a variable on there that's the one that we have this control over what we're going to do based on when we look at demand, you know, what are we gonna do with it? In our case, it is our decision variable. It's what should our order quantity be? And that's not always an easy decision, and it really depends on how you feel about your precision of your estimates for, you know, for the demand. Okay, so but we've decided to make it, you know, just for it to be $14.50. For whatever reason, and honestly, we're just starting here, because the whole reason we're building this model is to make it maybe potentially a better decision. Okay, to look at how these things affect each other and see what we should do. In this color coding convention that they use for your textbook, they shade this red. Now, a bright red would make it really hard to read the stuff up here, so we'll be using like a light red, often referred to as pink. But anyway, we'll be using this sort of lighter red color. And the other thing, the other shading color that they use is in your, what will be your outcome, your output cell, the bottom line, what you're looking at. For us, that's gonna be the profit, and they shade that in a gray tone. Those are the three colors. They use blue for input variables, they use red, light red, for your decision variables, okay? Which later, when we get into the part where we're solving it, which will actually start next week, that'll be what we ask Excel to solve for us, is what that value should be, or multiple values. And then the bottom line, the outcome variable that we're looking at will be shaded in gray. I will tell you real quick, and I do this, I don't know if this is in the book thing that they do, but I do this, and that's cells that we're gonna be entering information into. I put borders around the cells so that, in fact, on the test and other places, it's really clear to you. I mean, obviously the instructions say go to cell such and such and type in something, okay, but it'll be more clear to you, you know, because I'll always have those bordered so that you know those are ones you're putting something into. Because what you see on this sheet so far is everything we were given. Every bit of the information that we have is on here. I was telling you, it's a very little problem, but it does help us illustrate how we want to set things up and begin to introduce color schemes and everything else. So if our goal is to try to make the best decision here and order the best possible amount, I would assume that for most of us, we realize that that would be whatever makes us the most profit. Okay, so we're business students, so what are we trying to do here? We're trying to make the most profit possible. So that's why that's our outcome cell. Well, profit is a function of your revenue minus your costs. Okay, so that's eventually what we're gonna get down to. Therefore, we need to know our revenue and our costs. And that's how the model will work, is by getting the revenue, the cost, therefore the profit. And then we're able to play around with numbers, do what-if analysis on it, and say, you know, what's our best decision based on information we have or things that we think will be. Okay. All right, the costs are easier to do than the revenue. What's one of the costs that we have? What's one of our costs?
The annual maintenance cost?
Oops, we're not on that problem yet.
No.
We're still on the t-shirt problem.
Fixed and variable?
The fixed and variable, those are our two costs. And the fixed cost, and then the next one would be the variable. Okay. Remember that here, we're not hard coding any values in. We made an input area specifically so that we can reference that input area. So I'm going to reference the fixed cost. Here, I'm just gonna make a reference to a number I've already put in, because I'm not gonna be hard coding numbers later, not after I do it the first time. So basically, the fixed cost is just a reference to B4, whereas the variable cost is gonna be what? What's the variable cost?
Variable cost per shirt times quantity?
Yes.
Order quantity?
Yeah, so variable cost per shirt, they're $8 a piece. Multiply that by however many we decide to order, whatever our order quantity is. So B5 times B13, that's gonna be our variable cost. Obviously, it's all cell references, so if any of those things change, we order different amounts, even if somehow later the variable cost of the shirt changed, that would change. Okay, so those are pretty straightforward and pretty easy to put in there. I've got two different boxes listed here for revenue. I understand that all the revenue is coming from the sale of shirts. Okay, I got that. But what is a way that we could break down the revenue from the shirt sales? Even though it's all shirts, it's selling them differently. How would I break down that revenue? Think about what would I do to break down that revenue? It'll make it easier. Well, we kind of need to do it without having one humongously long formula. Well, we already did the cost. This is just revenue only. And revenue is, you know, quantity sold times selling price, right? That's revenue. Okay. but I kinda have two different things that could be going on here when I'm selling shirts. What are those two different things?
But I guess like discounting those.
Yeah, so am I getting to sell them at full price, or am I gonna have some left over and I'm gonna have to sell them at a discounted price? So I'm gonna break this down, because it will be much easier for us to put the formula in if we break this down into the ones that are the full price shirts that we sell versus the discount shirts that we sell. Okay, so I'm gonna break that down that way. Okay, we sell the full price shirts for what? $18. So how will I calculate, how do I know what's my calculation for full price shirts?
The order quantity.
Okay, is it going to necessarily be, the selling price times order quantity? Is that what it's gonna be?
Or, demand
Okay, is it gonna be selling price times demand?
minus.
Kind of on the right track a little bit, but it's a different way to look at it. So make this generic. Don't think about the numbers that are actually in our cells. Don't think about those numbers, okay? Is it selling price times order quantity, or is it selling price times demand?
Demand.
Okay. Anybody, how many people think it's demand? How many people think it's order quantity?
Is it that the company bought 1,450?
Well, don't worry about the actual numbers that are in there right now. Don't worry about those numbers right now, just in general. Okay. How many people think it's a trick question? Okay, it is. It's not necessarily always gonna be times demand or necessarily gonna be times order quantity. It's going to be times which one? And in what circumstances would it be demand? Under what circumstances would it be would it be the selling price times the demand?
Is it whichever number is lower?
Exactly. Because if you think about it, you can't just as a blanket thing say it's the selling price times demand, because what if you didn't, well, in this case, what if you didn't order as many as you have demand for? You can only sell what you got. Could you have sold more? Sure, but you didn't order them. And so it's times the order quantity. But on the flip side of that, what if you had ordered more than what demand ends up being? Well, what can you sell? You can't sell all that you, at full price, all that you ordered. People don't want them. You can only sell what the demand is. So it is kind of a trick question. It's not one or the other. It's under one circumstances it's one, and another circumstance it's the other. So you actually have to ask that question.
So in this circumstance, it would be quantity.
Yes, in this one, in this example, because.
And you wouldn't have sold any at discounted.
Exactly, because you didn't order as many as people wanted to begin with, you ran out, yeah. So, but we have to set the model up, of course, so that it can do anything, so that we can plug in different numbers and it's not tied to this example where this is less than that one. Because that is basically the question that we have to ask. We've got to know which one is greater. There are 4 ways that you can ask this. I don't care which way you ask it, as long as your logic follows after you ask the question. Do you want to ask if this is less than this, or if this is greater than this, or if this one's less than that one, or that one's greater than that one? I don't care. There's 4 ways you can ask this, but as long as your logic follows the way it's supposed to follow, I couldn't care less which comparison operators you put in here. Okay, so what do we want to ask? What would we like to ask? Is what? What? Pick one.
Is the fixed less than the variable? Is it full?
It's not fixed and variable, it's demand and order quantity.
If the demand is greater than the order
Okay.
quantity,
Is demand greater than order quantity? Okay. So again, like I said, I don't even know which way it's in the finished file. I do not know which way it's in the finished file. But here's what you just asked, is demand greater than order quantity? In that case, if that's true, then what is your revenue for full price shirts? It's the selling price times
The order quantity.
the order quantity. Okay. If that was false,
Selling price times the order.
yeah, then it would be the selling price times the demand. these are put in here is, depends on the way you ask this. Okay, so as long as your logic follows, you can ask any way you want, and it can be one greater than the other, less than the other, you know, it does not matter, as long as your logic follows on correctly after that. And so what you see, I honestly don't know in the finished file which way it's gonna show up, you know, which way you'll see it. I don't remember, I do this so many times in different ways. But that's our full price shirt, let's, revenue. Okay. Now, I know that you can look at this example and say, like you did, we're not gonna sell any at a discounted price, because we're gonna sell all of these right now at the full price. But our formula has to be set up to accommodate whatever might happen, any changes to any of these numbers. So we do still have to calculate how you come up with the discount price revenue. And basically, you ask sort of the same thing, right? And again, I don't care which way you ask it. What do you wanna ask? If what's what?
I guess if order quantity is greater than.
If your order quantity is greater than your demand. And that makes sense to me to ask it like that too, because it's when your order quantity is greater than the demand that you will have shirts to sell at a discount, right? So if my order quantity is greater than my demand, then what is my revenue from discounted shirts?
Demand minus order quantity.
Yeah, it's that excess of demand minus the order quantity times where the discount price is, yeah. So, and again, the only way that you're gonna have discount price sales is if you ordered more than you had demand for, in which case that excess gets multiplied by the $6 discount price. If this is false, then what's your revenue from discount shirts? Zero. Okay. Because you sold them all at full price. Which is our example right here. That's our example. We did order less than the demand numbers that are currently in the model. And then last but not least, profit is revenue minus cost. Okay, we happen to have it set up in such a way that we're gonna need to say the sum of the revenue, because we have two different breakdowns of how we got revenue, minus the sum of the costs. I mean, I don't really care, to be honest with you. You could say this plus this minus this minus, you know, I don't care how you put it in there, but it's the revenue minus the cost. That's gonna be profit. Right, so this is what this model has told us. It's told us that, given all the things that we know, and if this turns out to be correct, and we chose to order 1,450 shirts, that we're gonna have a profit of 13,750, okay? If we felt really confident in our demand estimate and we decided to make this 1,500, we would have made another $500. We would have made 14,250. That would have been nice. We didn't lose money the other way. I mean, than the lost opportunity money, you know, what we could have had, but it's not what we chose. But what if, but what if we had ordered that many and then the demand had only been 1,400? Well, then we would have made only 13,050. So, you know, and I could, you know, all day long sit here and play around with those numbers and see what that does to profit. Okay, and I could make some decisions about, well, how brave am I? How much do I think, how accurate do I think my estimates are? All those kinds of things. But I could lay it out in a more concise, straightforward way if I put that information into a data table. If I just went straight into a data table and put in the entire possible range that I think it could be, which apparently I think that the demand could be anywhere from 1,000 to 1,800. Okay, I mean, obviously I zeroed in on the 1,500, but if I'm being, you know, just, it could be anywhere from 1,000 to 1,800, then maybe it would be a good idea if I modeled this out, or, you know, did a little what if on it. And so I'm gonna do this 1,000 to 1,800 in increments of 100. that? It says in the row, do demand. For demand, for order, quantity. There we go. So if I believe that demand really could be anywhere from 1,000 to 1,800, then I would probably consider any order quantity between 1,000 and 1,800, right? So I'm setting up a two-way data table right now. I put the two inputs in, demand, order quantity. But I need to tell Excel, to make the table, I need to tell Excel, what do I want to see as the output here? Well, what do I want to see as the output here? I mean, what would make sense for me to look at?
The profit.
The profit. I mean, that's what I mean, that's kind of the idea, is we want to look at profit and see what it would be. Would I cover this up on another day? Yeah, probably. But today, we will just make a two-way data table out of this. Okay, with all the inputs set, corner tells me what it is I want to see, which is profit level. I would go into data, what if analysis, data table. It is a two-way table, so I have both row and column input. My row input I said was demand. Where's that? B10. My column input is the order quantity, B13. Set it all up. Put a reference to the profit cell here. Put in as my row and column input B10 and B13. I click OK. Make those numbers a currency-like thing if I wanted. But either way. Now I have every combination. And now, instead of me just changing this number, changing that number, changing this number, changing that number, I don't have to do that. I can look at this and I can say, what if I ordered 1,500, but the demand was only 1,300? Oh, well, I would have made only 11,850. What if? And I can do every combination of what I think are feasible, reasonable choices here. The good thing is you're never losing money. That's a happy good thing. When are you not making as much money? When you order a lot and the demand is really low, okay? Or if demand is really high and you didn't order a lot, you kind of lost out on the opportunity to have made a lot more money, okay? What you'll see when you look at this table is, if demand ended up being 1,000, what should I order? Well, the best that I would be able to do would have been to order 1,000, okay? What if demand ended up being 1,200? What should I have done? I should have ordered, there it is, the highest number, 1,200. What if it was 1,600? I should have ordered 1,600. What you'll figure out is that your absolute best that you could do would be to order exactly what demand is. And here's why. Now, that's easier said than done, but here's why. It's because we sell the discounted shirts for less than we bought them for, okay? So if we have excess shirts, we are going to lose some money off of the profit that we were making, okay? So if we were selling across, this would be a whole different ballgame, but it's not, okay? We're selling them for less than what we paid for them, so we really don't want to over order, okay? We just don't want to do that by a great amount. So, but when a minute ago I said that's easier said than done, we don't know exactly what demand is going to be. And that's why we have a table put together like this, but I was going to do this for you because you'll see it on the finished file. At every spot of demand, the best profit that you would get would be by ordering exactly what demand is. Okay, I already pointed that out to you a little bit. But again, do you always know? No. If you thought it was going to be 1,500 and you ordered 1,500, great, okay? You made this. But if you thought it was going to be 1,500 and you ordered 1,500, but it wasn't, well, then you only made this much, okay? Or if you ordered more, or if you ordered, I should say, less, because you thought, oh, I don't want to be, ordering too much. I'll just order 1,400. I think it'll be 1,500. And then, if you ran out, it really was probably 1,500. You won't know that for sure. You lost an opportunity of making another $1,000. You can play around this table all day long, but the bottom line is, that's what, but on a bigger scale, what the models, look like. you build a model. In our instances, we're gonna color code these things so that they all, you'll begin to see a uniformity to that part of it. The input area is the only place really that we wanna have hard-coded in values. Everywhere else, we wanna be referencing those cells, okay? But the whole point is, you base models on assumptions. We assume we could sell the rest of them at $6. We are assuming, or at least predicting, that our demand is gonna be, you know, the 1,500 units. And so it is always a good idea later to do the, what if I'm wrong about this? And our other models would be a lot bigger, you know, what if I could change prices or quantities of resources or labor hours available to us, or, you know, whatever it might be. That's the idea of what we're gonna be doing when we're modeling. Okay. Questions about this model? It's just a small model to get us going. The next one's a little bit different. We aren't going to jump right into the solver modeling stuff yet. We're gonna do another kind of problem first. It's called a time value, what we refer to as our time value models. And the reason is that we're going to be working with is setting up a model, laying out cash flows so that we can make comparisons between things based on some financial measures that are helpful to us, like net present value and internal rate of return and payback and things like that. So all of that information that you saw on the PowerPoint is in here, okay? So it's all here. We had 2 different machines that we were possibly going to, that we're considering purchasing, one or the other. Remember the things at the top of the PowerPoint slide that said, these are the things that we know that are in common about both machines, and that regardless of how we choose, which machine we choose to buy to produce it, we anticipate that our demand is gonna be 10,000, and we get a 40-cent per unit profit on each product. Okay, so that was in common between the 2. So you'll see those here. You don't have to worry a great deal about the shading in this model. It'll get more important later. But these 2 spots right here have hard-coded value, 40 cents, 10,000. Because of our formulas and the way we're gonna be doing things, it is easier for us if these things everything is lined up in each column. And so I wanted the 40 cents and the 10,000 in the next column too. But what I am not going to do, okay, what I'm not gonna do is just retype in 40 cents and 10,000. Because if I did that, I lose the flexibility in some of the what if analysis that I might want to do later. Okay, so instead, do I want the 40 cents here? Yes, I do, but I reference that cell to get it. Do I want 10,000 here? Yes, but I reference that cell to get it. Okay, we're really not gonna wanna type in hard-coded values more than once. Okay, we wanna put them in once, then we wanna reference them. Okay. Now, the other things were different. Their maintenance costs were different, their life expectancy was different, their annual production capacity was different. Those things were different. Okay? And so we see that there. So here's what we're gonna do. We're going to fill in a couple of things at the top. We would like to fill in the price. You notice that the price isn't there for either one of them. But if you remember, back to PowerPoint, but there was that quantity price break structure. You see it here. You know, if you bought one machine, I don't know why we have the 0 up there. Just ignore that. If you bought one machine, you paid the highest price, 2 to 4, 5 to 9. But that was different if you bought machine 2. It was, you know, here. So anyway, that's the price structure listed out that we had on the PowerPoint. So we can't just jump up here and put the initial cost in until we know what? What do we have to know before we're gonna know what the price of the machine is? How many machines we're gonna buy? Okay. So we really have to figure this out first, right here. How many machines are gonna be required? How do I figure out how many machines I'm gonna need? Take the demand and do what with it? Because it is based off knowing the demand.
Figuring out costs.
You know, take the demand, because we're trying to get a quantity of machines, and we we know how many we need in total. We also know how many each machine can make, right? So we take the demand and we divide it by production capacity of the machine, it'll tell us how many machines we need. Let me back up just real quick. I have talked about the fact that demand is uncertain. We understand that it is. But in most of the models as we go forward, we're gonna make one big assumption. I mean, I'll point it out if it's different, but a lot of times our assumption in the models we're gonna be working with is that we've done our research and that we have a really good idea of what demand is, right? That we're feeling pretty confident about that we're pretty close. And so what we will make in the model aspect of it, we're gonna make this assumption that whatever we predict the demand to be is what we will make, it is what we will sell, okay? So a lot of our models are just gonna have this underlying idea that we assume that we predict that our demand's gonna be 10,000, we're gonna make 10,000, we're gonna sell 10,000. Okay, so when I figure out how many machines, I take that 10,000, I divide it by what machine one, for instance, can make 1,200 units annually. I need 10,000. That leaves me with needing to buy 8.3333 machines, which could be problematic because they may not want to sell us a third of a machine. So we have to decide something, and that kind of goes back to that assumption I was just talking about. Are we just trying to get close? What are we trying to do? We are trying to make and sell 10,000 units. So therefore, how many machines do we need?
9.
We gotta have 9. And I need to turn that into 9, and so I need to round up that number. I can't just round it because it might sometimes go down. I can't have it going down. I've got to force it to round up to 0 decimal places. So I need this to tell me that I'm purchasing 9 machines. I can't have it telling me that I'm purchasing 8.333 machines. Now, everything there, okay, is, everything there, I just copied over because this machine doesn't make as much, so I would just copy that over, and I discovered that for this machine, I need 11 machines because it doesn't have as high an annual capacity, so I would need 11 of these machines. You know, what was it exactly? I don't know, 10 point something probably. I doubt this came out to exactly 11, you know, 10 point something, but it doesn't matter, I need 11 machines because I need to produce the 10,000 units. That now allows me to come up with a price. You see, I can come up with a price so I knew how many machines I needed. And what am I gonna use to go over there and find the price and put it in here? What command? Function? Which one? Index? Well, index, we have to know the numeric location. We don't know the numeric location.
VLOOKUP?
We're gonna use VLOOKUP. So VLOOKUP is looking up what? Well, it's looking up 9 machines over here and figuring out that they're gonna cost me $700. But it's looking up the 9 machines in this table. And my answer for machine 1, my answer is found in what column? My answer is found in column 2. Yeah. And what type of a lookup is this?
Exact.
So is it exact?
No, approximate.
And here's why. It's an approximate match, not an exact match. If our demand ever reaches a point where we need more than 10 machines, which, as a matter of fact, right here it does, we can't have it just trying to, you know, quantity price breaks have a limit. I mean, you get to your best possible price and they tell you if you order this many or more, you get our best possible price. We have to leave open the possibility that if we were changing demand and demand made it where we needed more than 10 machines, that this wouldn't give us an NA, you know, so this is not false. This one is actually true because we need the ability to be able to have more than 10, okay? And even in the next problem, we need to have the ability to have more than 10, the next machine problem. Okay. machine 2, I don't wanna copy it, I didn't even put in the references to be able to copy it, but there's one part of it that's different, so I'm just gonna type the whole thing again. I am looking up machines required. I am looking that up in this table. And my answer is found in what column? Yeah, now it's found in the 3rd column. It is still true, and in fact, if you put false in right now, you'd get an NA because this already does need 11 machines, and 11's not on that list. So, $300. So that is giving us much, but we couldn't get the price out of that VLOOKUP, we couldn't get the price until we knew how many machines. Okay, so we're doing pretty well. The next part is to fill in the cash flows, which would take way longer than the just 2 or 3 minutes that we have left right now. 3 minutes.
We can go to 1. We can go to 1.
What was that?
We can go to 1.
No, we can't, because some people have classes at 1.
Oh, okay.
We're good. We'll do it. We're close enough. We're close enough
Okay.
that that's all the 10 o'clock class did that we
Oh, okay.
didn't do.
All right, yeah,
Okay,
that's
which just put the cash flows there. You're gonna see this finished file at the end of the day anyway, because like I said, I'm not gonna go back and rearrange all these dates on these release dates, because it doesn't matter, because we're still gonna work through everything together. We're still gonna work through all this stuff. So you're real close. We're real close. By the end of next class, we'll be back on track again, all of us on the same place. So stop it here, save it here, because we're gonna come